This example continues on from the previous videos. In this video, PSpice is going to be demonstrated. So to start PSpice, I've started up a remote connect and then connect it to Animal. So to find it on the remote access, you're going to go under Programs and then scroll down to PSpice Student, and you're going to start the capture. On the terminals in the lab, if you use them, this may be under a different name. It can be under Cadence or OrCAD or PSpice. So you may need to look for it, and capture is the one that you want to start. So start capture. And on here, you're going to do File, New, Project. Type in a name. And select where you want to store it. And remember which directory you store it in. And you're going to select analog or mixed A to D. Create a blank project, and this will bring up the schematic window. If you select just a schematic instead of the other one, you will actually not be able to simulate it. When you open this up, you need to verify that there is this PSpice menu located on the top of this. If it is not, which I found at the beginning, you need to go to your directories. And I located where I was located, my local directory. I was saving them in, and then there's a Windows file. And on here, there's this capture configuration setting. Just delete that and then restart the PSpice, and it should reformat it in the correct configuration to work, since it does work on the main terminal. So if you get this error and you don't have PSpice here, try that. You need PSpice menu in order to simulate it. So the first thing you're going to do is you're going to place your parts, and you're going to draw your parts so that you have the same schematic as what we derived the equation from before. So here it doesn't find my resistor, so I have to open up Add Libraries because I don't have any parts located here. Each library contains different components. Analog will contain the ones that are mostly resistors, capacitors, so forth. The eval library is also very useful, and then the source one. So the eval library has different components that, I think that's the one that has the op amp. So I look for R, it finds R in the analog library, and I hit OK. And I'm going to place my R just by clicking. I can rotate it by Shift R, or I can go up under Place. Oh, they've moved it. So you can place it and then right click on it and rotate it that way. There's a rotate here if you want to rotate it back. Or again, Shift R is the shortcut for that. Shift P brings up the place part menu shortcut also. So I'm going to do that again. I do Shift R to rotate it, and I place that one there and this one here. And going back and looking at the schematic, I have a resistor here, a resistor going down, a resistor going down, and then the capacitor across it. So I want to place the capacitor. And then I want to wire these. To get rid of the symbol itself, I pressed Escape. So again, I can go up to Place and this time Wire, or Shift W is the shortcut. And I'm going to put a wire between each of these. And then I'm going to wire the bottom. And Escape again will get rid of whatever element I'm on. So I'm going to now place the source, and I want to place a source that has both a DC component and an AC component to it. So it's called BSRC, and it was in the source library. And I place that as my source. Again, wire and wire on the bottom, and then I'm going to place a ground on the bottom. And on the older versions, this is 9.2. On the new version, this comes up as a default of already a 0, but on the older versions, it does not. It still names it as ground. So I need to change. I double clicked on that, and now I need to change this to 0 and apply. And then I can close that window. And I hit no here. For some reason, it wants to save it as a different file. And I can double check that that did change it to 0 by double clicking on it again. Each time I have to say no. And then I want to change my values here. This was, going back, this was 10, 20. So I double click on where that value was and I type in 10. And this is 20. 20 and 10 nano. Units in here, small m is for micro, and if you want meg, you actually have to type out MEG for meg. Just a side note. So now I've drawn my schematic that I want, and I want to simulate it. I see that there's a little extra wire there. I'm going to delete that. So now I want to save it. And I'm going to go to PSpice and new simulation and type in a name for the simulation part. I always inherit it from none. And then I want to edit the simulation profile. And it didn't pop up for some reason, but you can see it was blinking down here on the bottom. So I want to do an AC sweep. This will help me to create the Bode plot. What this will do is do a start frequency to the end frequency. So my start frequency, I want to have it be a low value, but not 0. And then I want it to go to a really large number. So I'm going to go to 100. I think this went to gigs, so. And then I do 10 points per decade. And I do OK. And now I can do PSpice and run. And this will create the simulation. Here you see that there's nothing in my window so far. So up here I want to place markers. And if I go to advanced, I can do the dB magnitude of the voltage, which is what we want. And I'm going to place that right above the resistor where my output was derived from before. And I'm also going to do one, again, it was PSpice markers, advanced, and I'm going to do the phase of the voltage too. And I can just place those over each other. So now in my simulation window, both of those should come up. I can do that before I simulate or after, it doesn't matter. Now I want to separate these so they're a little easier to read. So I can go to trace or plot. I want to add a plot to window. And then I can copy. I'm just double clicked on that and I copied this. And now I'm going to select this one and add the trace. Go up to trace, add trace, and then I'm going to paste. This is the signal that will be plotted now in that upper window, and then I can delete it from the lower one. So now it's the same one as up there, and I can just select it, which highlighted it, and now I hit delete. So now I have my dB down here and my phase up here. And I can click on this and change the properties. Should add a cursor in there. There we go. Okay, and once I get my cursor, it shows me, I can move the cursor around. And down here, it's showing me the different values as I change the cursor. So I'm seeing that it's almost flat here at -6 dB. And then as it changes, and I go down -3 dB is where in the straight line approximation, that's where you usually have your cutoff frequency. So I go from the flat region, which is about -6, and I go down by 3, so it would be -9. And this is where I consider my cutoff frequency, or 3 dB frequency, or critical frequency. So that is at about 581 kilohertz is what that is saying. So I can compare these two. Large, to what I did by hand. This is the Excel spreadsheet I created. This time I plotted hertz versus dB and hertz versus degrees so that I can compare with my PSpice simulation. So on this one, I again have -6 dB as my main flat region. And as I go down to, there's kind of a big jump there, -12, -9, and it's showing that it is at about 636 kilohertz instead. So you see that there is some difference here. It was 581, and here it was 630, approximately 637 kilohertz. So there's going to be differences between the hand and the PSpice. The PSpice is more accurate. And I can also do a similar comparison to my Excel here. It starts off at 90 degrees. And also here, it starts off at 90 degrees, and then it starts to change. I have to select the window to get the cursors to move up. Hopefully they'll move up, and they're not. Okay, now they're on there. So I can see that it starts to change from the 90. '89, and then it starts to go down at about, so about 20, about 70 kilohertz, and here it's starting to go down. I lost where it was. At about 10 kilohertz, 16 kilohertz, and this is about 80 kilohertz. So somewhere in between there, which is similar to what we're seeing up here. And then it seems to be flattening out to 0 degrees, which this also does. So that concludes the comparison.